In this lesson, we'll look at quick techniques in modeling framed structures. So the structure I'm talking about is going to be a huge space frame which will form the roof and the floor to our building. And then that space frame structure will get supported by columns at various positions underneath, coming from the ground slab level here. So to get started, one of the things that I can point out that would take a lot of time is if you had to try and model each one of these segments or each one of the elements individually using individual splines and individual spheres as joints, and then go and copy that around or instance it around even throughout your entire building. You would end up with hundreds or even thousands of separate objects that would have to be all grouped together, and it would eventually be quite complex. So I'm going to show you now how you can use some base geometry to reference your form from or your geometry from, and then how you can very quickly go and create that entire structure using one element. So in my front view, I'm going to go in and create a sphere object, and I'm going to reduce the number of segments down to 4. What this creates essentially is a double tetrahedral shape, which we can now use as our base geometry. So essentially this bottom, if you have a look just at the square pyramid that is over here, is what a space frame is derived from. So we can go and work with this and basically derive or calculate what our geometry should be like. So I'm going to take this object and rotate it by 45 degrees to align it with our building. And then the next decision, which is quite important, is you want to calculate what your depth of your structure is going to be. Now this will require some maths and a couple of structural geometry calculations, and I'm going to use a value of around 2 meters just to keep it quite simple. Generally you will have a depth or a span to depth ratio, and I believe, if I'm not mistaken, for space frames it's around 1 to 60. So let's go ahead and choose a 2-meter depth. That means the radius of my tetrahedral sphere is going to be 2 meters. If I look in the top view now, I can calculate what my module distance is going to be based upon that tetrahedral shape, which is derived for me. So here I can see that it's about 2.82 meters. So if I had to go and increase this to about 2.1, you will see that our distance will be a neat 3 meters with an emission of about 3 centimeters there. So essentially, to round the numbers off, we could have a 3 meter by 3 meter module with a 2 meter depth, give or take a few centimeters here or there. So we essentially have a 90 by 40 meter form. If we have a look at the original base box that we created right in the beginning, we have 40 by 90 meters, and using a 3 meter module we would have to increase the width to 42 meters just so that we can have a neater shape. We could also use 39 and then have 13 segments, but I'm going to make it slightly wider because I know that our volume is a little bit, or our floor area is a little bit smaller than what it should have been based upon our area calculation in the beginning of the course. So knowing all of that information, instead of modifying this module and then instancing around, making quite a complex series of objects again, I'm rather going to go and choose a much simpler route by creating one huge plane, having it 42 by 90 meters, and then dividing it by those 14 by 30, giving me that 3 by 3 module across the entire surface. That means I'm going to be working with one form or one shape, one object, instead of instancing around a huge amount being 14 by 30. So let's go and instance, or at least isolate this object now, and we can now start working on our space frame. So the first thing to do will be to add an editable poly. I'm not going to reduce it or collapse it down to an editable poly. I'm going to keep my original plane object in the bottom of the stack, and I'm now going to select all of the faces on this entire object. So just Control A for that, and then if you go down to extrude, you'll be able to extrude each of those faces and then just select by polygon. That means you're going to be extruding. If I just look at the direction needs to be in the minus, so minus 2 meters. Each one of those polys is going to be individually extruded, which means that these sides, which are on between the different cubes that are now being extruded, are 2 separate polys that are face to face. Next, what I'm going to do is right-click while I still have that selection and choose Collapse. That means each one of those individual polys has now been collapsed down. And you can see that immediately we have one single object that has the correct module size and the correct depth based upon that original tetrahedral shape. The beauty with this is that I can now go and add a lattice modifier. Just type in LATT, enter, and you will immediately have a massive space frame. The beauty as well with the lattice modifier is it is very appropriate for these type of frames because you do have the joint option, meaning that you can have a round ball joint, and you can also increase or decrease the complexity if you do want to reduce your poly count. So again, you want to then calculate or at least know what the radius of your struts should be. I'm just going to use a value of about 0.05, so 10 centimeter diameter. Then for the underlying structure, because you know that a space frame will need to have a crossbar, we're going to use the same object, and instead of the editable poly with the lattice modifier, we're going to go and copy it. So I'm just going to now remove the lattice, and I'm going to create a copy of that object. And I'm now going to just remove these two modifiers, and on top of the plane I'm going to add another editable poly, and I'm going to now remove this extra strip that is happening over here. So I'm going to take these two edges, and then I'm going to choose ring, and then I'm simply going to hit delete on my keyboard. And in a couple of seconds you'll see how this space frame will now start to emerge. Next, I'm going to take this lattice modifier, and I'm going to copy and instance it onto this bottom editable poly. That means that I will be able to control the values, the thicknesses of all of these beams through one single lattice modifier. So there you have it. In a couple of seconds, you have gone and modeled an entire space frame. If I just go and look at this building like so, you will see that there you have it. And all of the edges are correct. And it didn't take too much calculation, knowing that we used most of the derivative geometry from this sphere object. So I hope that you enjoyed that lesson, just seeing how you can do that quickly. And then the last thing, just remember, don't try and model these individually unless you have to do a very detailed render of an interior or more of an engineering render. And just remember, when you are working conceptually, try to use single objects. Now, the other thing, just as a point of interest that I wanted to show you, is you can now work with a similar type of technique with more complex objects. Now, this I'm not going to be using for my building just yet, but I wanted to show you how you can take an object such as this and then modify it. For example, if I wanted to come in here and create a more complex object, I could come in and add another editable poly and start to take, for example, these two areas. I could choose to add smoothing, and I could start to move those up and down, and let's just have a look at what results we get when we do that. So if I do that, I can now move it downwards, and let's just go and move it ever so slightly down. I'm going to select these two areas, and let's just move that downwards. Let's increase this smoothing, and once you add all of your other modifiers back, you can see how very easily and how very quickly you have created a much more complex shape. So this would normally be very, very difficult to create if you had to work on individual objects. Because you have this single mesh that can now be moved around, you essentially have an amazing flexibility to your design, because you can essentially go and create any type of complex shape, and your space frame structure will just continue to be adhering to your base object that you're creating. So all of those complicated forms that you see made out of space frames that are modeled, this is exactly a good technique that you could use to get that done very quickly and rapidly. So we may go and do something like that around the sphere object. We may later on in the course go and modify that by pulling down this area, but I'm going to leave it simple for the moment, just so that we can focus on any details or complexity later on in the course. So that is it for this lesson. What I'm going to do before the next lesson is just to make an instance of this and reverse it so that I have the floor as well. So it's going to just be instance straight down. And then the next lesson, we're going to look at the secondary structure, which is going to be the one holding up vertically the space frame slabs that we've created. And that's going to be happening very soon in the next lesson.